In this video, we're going to use the Calc Intersect features of the TI calculator in order to solve a couple problems. In the first problem, we're asked to solve the equation 5 equals negative 2x squared plus 3x plus 6. In order to solve this problem, I'm going to view the right side of the equation as a quadratic function. It is the function f of x equals negative 2x squared plus 3x plus 6, where we input x and we output y equals f of x. Now we're asked to find where is this function f of x going to have a y value of 5. Alright, in order to find where the function negative 2x squared plus 3x plus 6 has a y value of 5, I'm going to first graph the function in the calculator, and then I'm going to see where on the graph reaches a height of 5. So I first put the function in the y equals menu in y1. So in y1 I've placed negative 2x squared plus 3x plus 6. In y2, I've put the value 5. I want to find where the function f of x has a y value of 5. Now, when we graph it, notice that y1 will be a parabola that is open down because the leading coefficient is negative 2, so it will be a parabola open down. Since we have in y2 the equation y equals 5, y2 will create a horizontal line through a height of 5 in the xy plane. And so here is our graph. I've used a standard viewing window, negative 10 to 10, negative 10 to 10, to graph this. Now I see here my parabola open down, and I also see the horizontal line at a height of 5. Now that horizontal line is there to show us exactly how high 5 is on the graph, and you can see clearly two places where the graph of y equals 5 intersects our parabola. The places where the graph intersects our parabola would be the two places where the parabola reaches a height of 5. We want to find those exact places where our parabola reaches a height of 5. In order to do that, we can use the Calc Intersect feature of the calculator. We first hit the second button and then hit the trace button in order to access the calculate menu. I want to find where the parabola intersects the line y equals 5, so I select option 5, intersect. The calculator walks me through a series of questions. It asks me, is this the first curve that you want to intersect with? You notice that my cursor is sitting on the parabola right now. I can tell that because up in the left-hand corner it says y1 equals negative 2x squared plus 3x plus 6. That's where my cursor is sitting, on the first curve. And the calculator is asking, is this the first curve you want to intersect with? Yes, it is. So I press enter. The cursor then automatically jumps to y2. Notice in the top left-hand corner, my cursor is telling me it's now sitting on y2 equals 5. And the calculator asks me, is this the second curve you want to intersect with? And yes, it is. So I press enter again. And lastly, it asks for a guess as to approximately where the intersection occurs. You can take your cursor and arrow it left and right until it's sitting approximately on the intersection point, and that's approximately it there. And then press enter one last time. And it calculates and says the intersection occurs at approximately x equals negative 0.28077764. Notice I am using an approximately equal symbol here because this is a rounded value. We can solve for this value exactly using the quadratic formula, which we'll do also, but for now this is an approximation of the solution. There is another solution. So we're going to go back to that graph, and I see on the right side in the first quadrant there appears to be another place where our parabola intersects y equals 5. To find it, I'm again going to just go through that same process. I hit second, trace, select option 5. It asks for first curve. I press enter. It jumps and asks, is this the second curve? I press enter. It asks for guess, and I arrow to the right to put the cursor on top of that intersection and press enter. And it says the intersection occurs at approximately 1.78077764. So there are two solutions, two places where negative 2x squared plus 3x plus 6 will reach a value of 5, and these are the two answers. And these are both approximations, not exact answers. In the next example, we want to find the x-intercepts of the function f of x equals 6x squared minus 7x minus 6, and we're going to do it graphically. Then I'm going to round my answers to 4 decimal places. Again, we're going to go to the calculator, put the function in the y equals menu, and this time, since we're finding x-intercepts, we're going to find the places where the graph hits the x-axis. Remember, x-intercepts occur where y equals 0, where the height of the graph is 0. So we need to let y equal 0, and we also need to let the other y equal 6x squared minus 7x minus 6. So I'm going to put in y1 the parabola 6x squared minus 7x minus 6, which will be a parabola that opens up. And in y2, I'll put the horizontal line y equals 0, which is just a horizontal line right through the x-axis. And then I'll find where do those two things intersect. Where does 6x squared minus 7x minus 6 intersect the horizontal line y equals 0? So here is the parabola that opens up. It also did draw a line y equals 0 right through the x-axis, although we don't see it because it's right on top of the x-axis. I want to find the 2 points, the 2 places where this parabola hits the x-axis, where it hits y equals 0. To do that, I'm going to use Calc Intersect. I hit second, trace, select option 5. It asks, is this the first curve? Yes, I press enter. It jumps and says, is this the second curve? Yes, so I press enter. It says, can you give me a guess as to where the intersection occurs? I move my cursor to the point on the left, press enter, and it says the intersection occurs at approximately x equals negative 0.5744. I want to find the intersection point on the right side as well, so I go through the whole process again. Second, trace, option 5, intersect. It asks, is this the first curve? Yes, so I press enter. It asks, is this the second curve? Yes, so I press enter. It asks for a guess. Since I want to find the one on the right, I move the cursor over until it's sitting on the intersection point to the right and press enter. And this time it says the intersection occurs at approximately 1.7410. So the 2 x-intercepts that we found were approximately negative 0.5744, comma 0, and 1.7410, comma 0. Those are the 2 x-intercepts rounded to 4 decimal places.